Hello everyone. Today I am presenting an assignment of my exam. First of all, this is question paper, and first question is write an algorithm to accomplish the task for polynomial p of x given in the following table. This is equation, and this is solution. In question, we giving a polynomial p of x of n plus a n minus a n minus 1 and x minus n plus data dash. First task 1. To calculate this, we can use the two approaches. Brutal force approach. In this brutal force approach, we can compute every term like this. In this method, computing the x power of k tax k multiplication k multiplication. So algorithm. First of all, we start then for loop going from n minus 1 to 0. Decrease one by one. And it is initialized into sum, which are variable, and return the sum and then end the algorithm. The time complexity is big of n square. The second approach is recursive approach. Using Horner method, we can rewrite the polynomial as the this is equation of polynomial algorithm. Evaluate a function which have two arguments. Have one condition if I is equal not equal to 0. So return a of I and return the whole function. Then the time complexity is big of n, and task 2 divide p of x by x minus y. Brutal force approach algorithm. First of all, start then read an array from n 0 to n, and the value are initialize stamp vary an array and also echo another array. For the and then we starting a loop from I for n to I and step of one mass decreasing. This temp I is initialized in array in count of I of n for j of from 0 to y to b. The temp also initialized by 10 minus j and also another array. Reminder also initialized by temp I and print the quantity and reminder and end of the all algorithm. We consider first another approach, a recursive algorithm. Start input degree and another array and the R value. Define the function and synthetic divide by R and a of I and a. If I is equal to then return a of 0. Else return I a of I plus R into in the into again they going to the same function and call this function and store the result output of result and end the algorithm. Task 3 derivative of d of x. Brutal force method. Start input degree and coefficient and other array. Initialize the derivative list d of in d of array for another we हमने एक और लूप लगाया है आई से एन आई जो 1 से लेकर एन तक चलेगा और हमने अपेंड किया है यहाँ पे इन द एरे आई इंटू ए ऑफ आई एंड आउटपुट किया है वो एरे को और एंड एल्गोरिदम को रिकर्सिव एल्गोरिदम स्टार्ट हुआ रीड एन हुआ अनदर एरे हुआ डिफाइन ए फंक्शन डिफाइन करेंगे जो डेरिवेटिव नाम से और वही अपने यहाँ पे दो कंडीशंस लगाई है रिटर्न की फिर उसे फंक्शन कॉल किया स्टोर किया रिटर्न किया और एंड हो गया एल्गोरिदम. अब another question is coding or hello everyone, welcome in general algorithm. Start input n and to check the operations subtraction, multiplication and division. Perform the operation. Display the result in scientific notation. End of algorithm. N1 and N2. This is the value First of all, we subtract both and common the 10 to the power 99. Now this is result. This is final is 2.8 EE and 102. And task 2 is N1 and N2 this and the multiplication of both of them. The final is 1.37074 E in 164. The task 3 division. The N1 and N2 this is then the division of both of them, the final is 9.998 E 99. The association law check A plus B into 2 is equal to A plus bracket B plus C. Giving them both, the value is this. Uh, so question number 3 is verify associative law and distribute law of arithmetic with fitting for Manhattan's digit. And the provide correct answer if no number is truncated for the Gauss equations. So the step 1 is compute A plus B plus C and whole bracket of C. Convert all in numeric numbers to decimal. This decimals, then the addition of A and B and the addition of A plus B in whole bracket of C. So the answer is 11.364 and 56. The step 2 is to compute A plus B bracket B plus C. Bracket complete. B plus C is equal to 5.69956 and the addition of A is equal to 11.36456. Both results are equal. Associate and law is verified. The task 3 is division. Okay, 1 minute. So distribution law check. A into B minus of C is equal to AB minus AC. So given this equation and on the step 3, step so I'm back, guys. So we in step 9. Compute A into B bracket of whole B minus C. B minus C the 0.0454 and minus of 4.5553. This is answer is minus of 4.507. So multiplication of them with 5.555. The solution is the negative 25.0457. Step to compute AB minus of AC. First of all, AB into AC. So AB, the result of AB is 0.25243 and AC is 25.29. So minus of both them is also it's negative of 2.25.04255. The both result are equal and distributive law verified. So fourth is true and false. Minimize the number. First of all, minimize first true false is the minimize the number of arithmetic operation whenever is possible. So it is true. Avoiding taking the difference of two nearly equal numbers whenever possible by alternate formulation of the problem if it can't be avoided. Take the difference before doing the other operation. True. Adding or subtracting a number start with the smallest number and work with the number ascending or true. Do not formula. Do not formulate an algo that tests whether a floating point is equal to 0. It is also true. Fifth is ill condition of the problem is normally due to improper formulation and can be eliminated by carefully reperforming the problem and practical way detect the suspended ill condition is alter the parameter by the smaller amount of observe their effect on the solution It's also true. After the numerical algorithm is obtained, check if it can be lead the numerical instability and in such a algorithm error. Grow each step of calculation in such a case reformulated the solution procedure to get a stable numerical. So it is also true. The seventh is seven rounding. The seven rounding error and consequently loss of significant digit are antiseptic and no alternate formulation. To avoid this possible, then carry more significant digits in the critical calculation using the float point number in double precision mode. In this mode, length of matrix is twice that the floating. So it is also true. Eight is double precision requires larger memory space and slow down the calculation. It is also true. Ninth is in the third iteration of finding square root of the five with the starting points using Newton's reforms. It is also true. The iterative and tenth is that the iterative method are compared on the following parameter. It is also true. So thank you for first internal. Thank you a lot.